a vector has both magnitude and direction. Here we have a vector that's magnitude of 10 newtons and whose direction could be described as 30 degrees on the north side of east, or 30 degrees north of east. So, a vector like this will have both eastward, this way, and northward forces. A 10 Newton force at 30 degrees north of east acts both eastward and northward. Now you can see I've marked in here the eastward component and the northward component of this 10 Newton force. We can calculate these two components when we decompose that 10 Newton vector. The two components of our 10 Newton force here, the eastward and northward components, can be considered the eastward or horizontal x component and the northward or vertical y component. To solve these two components of this right triangle that we've created, we can use, with the right angle here, we can use trig. Okay, we're all familiar with SOHCAHTOA, the acronym that tells us how to use the sine, the cosine, and the tangent when referring to right angle triangles. In this case, I'm going to use the sine and cosine. I'm going to use the sine of the 30-degree angle to equal the opposite side, which I've called y, divided by the hypotenuse side, which is 10. Solving for y, I get 5 newtons. And also, to solve for x here, I used a cosine, which is equal to the adjacent over the hypotenuse. The adjacent side, in this case being adjacent to the angle, is x, and the hypotenuse being 10. Again, solving for x, I get 8.66. So in this way, we can calculate the components, both x and y, for this 10 Newton force. Please note that 5 and 8.66, these two components, when added together, will not add up to 10, and you shouldn't expect it to, right? The square of the 5 plus the square of this will equal to the square of that, Pythagorean theorem, but the values themselves do not add up to 10. Okay, so here we have an example of a question where we're going to mathematically add vectors, force vectors, 1, 2, and 3. Force vector 1 is 10 newtons at 30 degrees north of east. And you can see I've already broken that down into a eastward x component and a northward y component, which I've calculated here using the sine and cosine to be 5 and 8.66, if I take everything to 3 sig figs. I'm going to add that to a 5 Newton northward force, F2, and a 2 Newton westward force, F3. Now, one of the ways I choose to add these forces is to help me organize things, is to place them in a table. I'm going to add the x and the y components separately. So to organize that, I placed them into a table. You can see here for F1, that's F1, there's a positive x and a positive y, because those are positive directions. And I've included that here. For x, it's 8.68, it's positive. And for the y, it's 5, it's positive. For F2, it only has a vertical component. For y, there is no x component. So you see here for x, there is no component. And for y, I have a positive 5. Again, it's pointing upwards, that's a positive direction. For F3, I have no vertical component, and I have a negatively directed horizontal or x component. So here you can see -2 is my value for the horizontal x component, and there is no component for the y. Now, what you're going to do is add the vector components for the x and the y separately. The 5 here and the 5 here will make a total of 10 newtons vertically. The 8.66 and the -2, when added together, will make a 6.66 Newton horizontal force. So we have now created the 10 and the 6.6, the two values for the x and the y component of the resultant. If I want to quickly sketch it, it'll look something like this, okay? So I have a positively directed x component of 6.66. I have a positively directed y component of 10. And my resultant would have to be this. Let's find that resultant vector. We can do that using Pythagorean theorem. And we can solve for this angle here, which would give the direction of that resultant vector using trig. Okay, you see I've done some work now. I've taken my components of 10 in the y and 6.66 in the x here of my resultant, and I've used Pythagorean theorem for this right triangle and calculated that resultant. Here's Pythagorean theorem, and I've gotten 12. So the resultant of these three vectors, when added together, is 12 newtons. Now to describe the direction, I need to know that angle. It'll be on the north side of the eastward direction. So to do that, I've used trig, and I've picked up tangent here. The tangent of the unknown angle is equal to the opposite over the adjacent. The opposite here over the adjacent, 10 over 6.66. Using the arctan here on my calculator, that's usually shift 10 on most calculators, I've determined that that degree is 56.3 degrees. So my final answer then in the box at the bottom here says that the resultant of those three forces added together will be 12 newtons, give it to 3 sig figs, at 56.3 degrees north of east.